So this video is about the elements, and this one goes pretty deep. There's a lot of different directions you could take on talking about this topic, but I guess I'll just start with the philosophy side of it and kind of where I got this idea to begin with, and then how it kind of strings along through different things. So this book, The History of Western Philosophy of Bertrand Russell, it's a really good book. I would highly recommend this one. This is like a starter for, it takes you through all the philosophers in a quick summary of what they believed and just kind of the chronological order of all of them, how they all connect together and kind of bounce off each other's ideas, but it's very concise and like summarized very well. The birth, I guess, of philosophy starts with Thales of Miletus. It's an island. And he believed that the primal substance of everything is made of water. And this is like the primary element that everything comes from, I guess. And then as you go through the philosophers after him, they kind of had different views according to what's the, the primary source of all things, or what is the, everything is made of this element. So Anaximander had an argument to prove that the primal substance could not be water or any other known element. If one of these were primal, it would conquer the others. Aristotle reports him as saying that these known elements are in opposition to one another. So then you go through the history of the Greek philosophers, and they have these four elements of like fire, water, air, and earth. And I didn't really want to talk about that topic, but I guess just to kind of start it out as the foundation in philosophy about the elements. But they had an idea that the element is the primal substance, the foundation, the what everything is built upon. It's an indivisible source that everything comes from, this one thing. And when you think about your schooling, you go to elementary school where you get the elementary foundations of all the topics you're going to build upon. It's the starting point that you build upon. And also, it's just the primary source of everything is the elements. It all starts with the elements. It's the foundation. It's what everything's made of. You think about like the elements of nature, someone would say like surviving the elements. It's what everything is made of. So there's another book, Euclid's Elements. And this is just a famous like classical text about this Greek mathematician Euclid, who wrote this book, The Elements, or Elements, of 13 books about just geometrical proofs. He was just like a genius in math. It's the foundation of all geometry, and you could say a part of mathematics as well. And it starts with like these proofs where he'll give an example, and he'll go through these different axioms or postulates to come up with these theorems, or he's basically demonstrating how this is the case of something. And it's all mathematical. It's all derived from a precise measurement, I guess you could say. And you think about chemistry and physics, which I think most people think of chemistry and physics when they think of elements, of like the periodic table of elements. And it's a periodic system that's all mathematical. And if you look at the history of how the periodic table was formed or discovered, it was Mendeleev and Lavoisier and these chemists, but they were just mathematicians in a way, that the way that they found this periodic table of all these elements wasn't from like, oh, now we found this element, let's add it to the table. It was a mathematical system that the math worked out that there has to be this many elements because of the atomic number and the ratios and how much the atom could hold in its orbit, or in its nucleus, its orbital rings, how, the weight that it could withstand until it just couldn't even be stable, and like the polarity of it. So all the elements are mathematical. You think about Euclid's Elements, that starts from math. the foundation of everything. You think about the periodic table of elements, and everything in this world, this universe, is made up of these fundamental elements that we know of. And we could put it on a table, which is like a crazy human achievement. And I guess I was thinking about how you could relate this to your life, about everything starts at a foundation. There's certain elements of everything. Like whenever you're studying a new topic or anything in your life, you know, there's the elements of math or the elements of psychology or the elements of whatever you want to fill in the blank with. There's a foundation that you start at, that you have to build upon. Axioms, they're like self-evident, or like these kind of a priori, like they start at this, then they build upon this. And I guess, also I forgot to say the definition of what an element is. It's a fundamental or basic component of a whole. So when you think, it's kind of synonymous with atoms in a way, but there's all this different modern stuff about atomic theory and things like that. But if you read The Great Ideas by Mortimer Adler, he talks about the elements, and he talks about how there's the atomist, which also goes to the philosophers of Democritus and Lucretius, and the atomist of the Greek times, and they didn't even know what the atoms were, but it was defined as like the smallest unit. It's indivisible. It can't go any smaller than that. And he also talks about how where we've come today in modern times with fission and fusion and like quantum theory and all that stuff, and quarks and all that stuff. But the whole point was there has to be a foundational element that everything stems from. And it kind of has to be like you trace the line of something, a compound or a constitution of two or more bodies that you break down into smaller and smaller parts until you get the smallest part. And what's the point where it can't go any smaller? It's indivisible. It's the smallest units we have. That's the elements of everything is made up of those. And I guess that's the whole study of physics and stuff. But I guess in your life, you can take kind of a reductionist approach to everything that's complex, or I guess you could think of it like a compound. Things combined. When elements are combined, they become a compound, or a constitution of two bodies becomes a compound, and it becomes bigger and more complex. But if you break it down into smaller and smaller parts, into the elements, into the fundamentals, then you can get a better understanding of the principles, the causes, and you can build upon that to grow. And whatever seems very complex can be broken down more and more and more until you get something very easy to digest or easy to understand. And you start with that. You start with the foundation, the fundamentals, the easy things, the elementary things that a child could learn. And then you start building upon, building upon, building upon. And anything in your life that very difficult, very complex, start at the very basics, move on slowly, and build up. The simplest parts is what the elements are. There's a whole story behind chemistry, I guess. It's really just an interesting story about, if you read about like Robert Boyle or Lavoisier or Mendeleev or Moseley, or these different chemists, that the way they discovered this stuff is just kind of mind-blowing to begin with. But it started with first it was like a renaissance where they took the Greek ideas about the atom or the four elements, and they started kind of rejecting it or tweaking it in a way that there's not just four elements: fire, air, earth, and water. There's not this, there's four elements, but there's actually a lot more elements that make up this world. And they kind of started with a select few of, like, you know, the basics, carbon, or, you know, sodium, or just something that was these gases that were discovered, and then it kind of built upon, we know more and more and more, and they kind of separated them and categorized them into gases and solids, metals, or whatever. And it kind of changed how we view the world in a way. I mean, the whole field of chemistry just exploded after that, and then we started creating a lot more artificial things with those chemical ingredients, I guess you could say. And that's really what elements are as well. They're ingredients. I mean, it's how you build something, it's how you create something. If you want to make a piece of food, I mean a cake or something, you know, you have the basic ingredients that you need to use, that the foundation to create this thing. Or if you're going to create a masterpiece of, you know, Da Vinci masterpiece, he had to have the basic colors or the ingredients, the elements to create that. Also, any type of innovation, you know, you had to start with the basic elements. But I guess as we get more advanced with technology, we found a way to transform the elements by combining them. And once we have those combined in these different compounds, we combine those together, and it just gets more and more complex. So you have like not just the element of like silicon, but you have computers and very complex machines and things that are just kind of surpassing what the basic elements we thought they could even do. It started with like, you know, the steam engine, or ways that we're transforming the elements into something useful, and now it's just become very, very complex. I think that's pretty much it. One last thing is it had to do with the whole and parts. So elements are parts, and they can make a whole, but they're the basic component of any whole. So anything that is complete or whole has the basic elements in it, different parts made up of it. Yeah, I don't know, it's pretty interesting. One final thing is just the fact that I guess Abraham Lincoln read Euclid's Elements, and I read some of it, a good amount of it. It's just a lot of geometrical proofs. I mean, unless you really love geometry, it's kind of hard to just go through the whole thing reading it like a book, 'cause it's more just like a math textbook. But I guess it's supposed to help your mind think better, or just the way you reason or use logic. If you have a mathematical background, it kind of advances it a lot. When Abraham Lincoln was reading this, I guess it was his way to fully understand how to demonstrate something and how to prove something. And once he read this book, he could kind of give a full demonstration what it was, and he understood equality, and it also led to his, you know, freeing of the slaves, because he believed that people are equal, and it came from this book about geometry, and it talks about equality. And I'm not really good at explaining it because I'm not really too deep into math, but I want to be better at it, I guess. I'm trying to learn. It just teaches you how to demonstrate, how to prove something. So like in the case of a court of law, or how to reason or think logically, or how to come to you have premises and you come to conclusions, to how to have a clear way of thinking. You need to think how Euclid thought, that you have an axiom, you have a starting point, and you build upon it, and everything connects to each other in a way that they build upon each other. And if the first thing's wrong, all of it's wrong. But you start at the beginning, you start at the foundation, and you work your way up. And that's just like a rule of life.